So one of my subscribers pointed me to this fellow here. Mr. BBB333 apparently likes to promote things that are outrageous and completely false. And one of the stories that he's trying to promote here is that the Earth is tilting south, and that the sun is too far north, and he provides proof. So let's go through this. One of his observers actually confirms the phenomena, but doesn't really confirm anything. So the premise behind this is that weather is happening in weird places, and that it's, intense. There's hailstorms in Spain, for example, but hailstorms happen all over the place every summer. Picking one location like Spain is not unusual. They have hailstorms there. They have hailstorms even in Canada. They have intense hailstorms sometimes up there. So whether or not a location has a hailstorm or a tornado does not make things weird or wonky. But this is what he says.
Something appears to have changed. We can go back here to the weather map and I'll show you. You can see the intense storms over Maine. So there they are right there. There's the tornado generating storms. It's like this severe weather has moved north about 8 degrees. The severe weather normally is in the center of the United States, consistently. I don't remember all of this severe weather being up in the northern part of the country. It's as if something's changed.
Nothing has changed. And his memory is really bad if he doesn't recognize this from year to year, because it happens every single year. Every single summer, the weather patterns shift north. And every single fall and winter, they shift to the south. And the reason they do this is because the area where the sun is directly overhead, where the maximum amount of energy from the sun is deposited into the Earth's atmosphere, shifts north during the summer and south during the winter. Because the Earth's tilt with respect to the orbit of the Earth around the sun is 23.5 degrees. That tilt of 23.5 degrees means that as the Earth moves in its orbit around the sun, it's going to expose more of the north to light and more intense light, and then during the winter, more of its energy is deposited to the south. I can show you this most easily if we look at a simulation of the Earth and its orbit around the sun. And I'll show you that the polar regions of the Earth get sunlight or lose sunlight depending on the seasons. So to do this, we're going to look at the Earth. We're going to zoom in on the Earth as it is going around the sun. Let's back it off just a hair. And I want to actually center my camera over the pole. So to do that, I need to move this until the rotational axis, which is that blue thing I'm moving, is right close to the middle of that circle. So now we're looking straight down on the north pole of the Earth. You can see it right there. Okay? Actually, I'm going to leave that on as we go around. Now pay attention to where the sun is shining. Right now the North Pole is not getting any sunlight because it's winter time. See over here? It's January. Now we're going into February, and now the sun is coming back. Now the North Pole is always in sunlight. And it's June. And now it's rotating back. Now it's in darkness again. And this happens because the Earth is tilted 23.5 degrees with respect to its orbit around the sun. So right now, as we're coming in on June, more energy is being deposited into the higher latitudes than it was during the winter time because the sun is reaching higher latitudes. And now, during the fall, the sun does not reach as high a latitude. It doesn't shine into the polar regions, so the energy deposited from the sun into the Earth's atmosphere is in the lower latitudes. And now it's going back to the high latitudes. This is the reason why weather patterns shift from the south to the north, depending on the season. This is not rocket science. This is stuff that people should learn in grade school. It's a pretty basic tenet of our Earth. So now you can understand a little easier, perhaps, why weather systems shift to the north. But there is one other thing that can affect whether or not weather systems travel further north than usual. Weather systems are affected by winds. They're driven by the winds. And for storm systems, the middle part of the atmosphere is the part that drives and steers these storm systems. Just like if I pushed on your back, I can steer you more easily than I can steer you if I push on your feet or if I push on your head. If I push on your back, it's easier to steer you. Well, it's the same thing with weather systems. If you push on the back of a weather system, you're pushing and blowing wind in the middle part of the atmosphere. And the middle part of the atmosphere is defined as an area known as the 500 hectopascal pressure level, or the 500 millibar pressure level. That's another word for it. So 500 millibars is the middle of the atmosphere. It's the middle part. And every single day, weather stations from around the world send up balloons that measure the winds at those altitudes, and they track the winds. And then they produce weather charts that show how those winds are blowing. Here's a 500 hectopascal height contour map, or in other words, it's a map that shows the height of the 500 hectopascal or 500 millibar pressure level around the world in the northern hemisphere. And this is really interesting because it shows not just the direction that the winds are blowing, they always blow from west to east because of the rotation of the Earth. Except in intense low pressure and high pressure areas where the winds can actually go in the opposite direction, such as up here. But the winds are always going to follow from west to east unless they get wrapped around a low pressure system here, where they'll spin in a circle and go in this direction in a circle. But for the most part, they travel from west to east. And the distance between the contours defines how strong the wind is blowing. If there's a greater difference in pressure between regions, you'll see that these contour levels are close together, such as here. The difference between this high pressure and this low pressure is producing a gradient in the pressure that is rather steep, and that steepness drives stronger winds. So you can tell the velocity more or less by looking at how closely spaced these contours are to each other. So in this region, the wind is blowing really rather hard, whereas down here, where the contours are so far apart, the wind is not blowing very hard at all. In fact, it's really rather calm. Now I'm focusing on the solid contour lines. The dotted contour lines refer to the thickness of the 500 millibar level, and we're not really paying attention to those right now. I'm looking at the solid contours. So these winds that are blowing at this 500 millibar level are pushing the storm systems right on their back, and they're steering them. So in this area here, a storm system that forms near Vancouver Island right here is going to travel towards the northeast and reach northern Alberta and northern Saskatchewan and northern Manitoba before starting to travel back south again towards New York and the eastern seaboard. This is how storm systems travel. They follow these contours. They're driven by them. So this is another reason why storm systems might appear to be much further north than you'd expect, because in this particular case the storms are being driven north by these winds. So this level also defines where the jet stream blows, and the jet stream in this particular case is located roughly where this solid black line is, and it follows roughly that solid black line. So the jet stream is really quite far north, and it defines the region that separates hotter air in the south from colder polar air in the north. If the jet stream sinks to the south so that it's like through the central United States, then the northern part of the United States would be in colder air, and the southern United States would be in hotter air. Storm systems like to form on the boundary between that hotter air and colder air. That temperature gradient feeds energy into the storm systems. So that's another reason why you'll see storm systems in the northern part of Canada, where they might otherwise be located further south during the winter time, because the jet stream moves north during the summer and it moves south during the winter. So now compare this picture here of these clouds and these storm systems with what we see on the 500 millibar map. These storm systems here are north of Vancouver and traveling towards northern Alberta, northern Saskatchewan, northern Manitoba, and then they're coming back down into the northern United States and southern Canada, exactly like this map shows. See that? They're following the same exact pattern because these winds are steering them. Once in a while, you will have a storm system that becomes rather intense and causes the wind to wrap much further north than you would otherwise expect. For example, if we look here at these contour maps, now these are a little bit different. You're looking at the black lines. The black lines correspond to the same black lines on the other map we showed. But the colors define the vorticity of the atmosphere, and the vorticity of the atmosphere is how readily the atmosphere is spinning. If an area of the atmosphere is prone to spin more easily, it will form thunderstorms more easily. And you can tell those areas that are more volatile for the development of storms by looking at how rapidly vorticity changes. You're not looking at the intensity. So a deep blue does not mean that a storm system is going to form. But if it's really close to a deep red, or maybe this is kind of a rusty red, if they're really close together, such as is the case here, then you'll get thunderstorms forming more prominently in that area. So this area here is more prone to thunderstorm development than this area over here. But back to my point, you'll get these storm systems that form and cause the 500 millibar winds to blow more directly north. Now pay attention in this case to how the angle of these contours pointing towards the north, and watch how that changes according to the forecast. It changes so that it looks like they're traveling more east-west now in this area, but then a storm system forms right here where they really start to pull to the north in this area. So another thing that this does is it takes this really warm air over the ocean and it pulls it to the north, which increases the temperature on the ground in this area here, because all that warm, moist air is being pulled up here. That can also contribute to the development of storms in the north. And see how it even pulls more radically north here? Now the storms that form over Vancouver are being pulled almost straight north into northern British Columbia before they start changing direction and going back towards the south. So these 500 millibar winds really do have a strong impact on storm systems. They're one of the most useful tools for meteorologists to track and quantify storm systems. So that explains why weather systems move to the north. Shouldn't need to say anything more about that. But as evidence that this guy claims that the earth is tilting, he uses a video from a farmer in Michigan where he shows a solar panel, this solar panel here, which the farmer claims is not working properly because the earth has tilted. But let's listen to what they say about it.
Big observation that I know a lot of you have noticed too. I've noticed it myself, not only with the sun, but I've noticed it with the moon. They seem like they're out of place. So let's just say, and this is a good example here, he's going to explain to you how he's noticed that the sun, and he can prove it with his solar panel here. This is the way the solar panel was configured for the sun, and now it's not in the sun like it always has been, and he's had to move it.
Which is probably the reason why it's not working, because if he had to move it, then he's tampered with whoever originally installed it. And whoever originally installed it knew what they were doing and would have placed it in a location where it could have received maximum sunlight during one portion of the year. Unless there's a steerable motor on the back of that to track the vertical motion of the sun as the seasons progress, it's not going to be pointed in the right location. And I can tell you right now, just by looking at this, that it's not tilted nearly enough to maximize its energy production during the summer. It looks like it was installed to obtain most of its energy during the fall or the winter, because the angle of this solar panel is not right. During the winter, the sun at noontime is closer to the horizon, and so the angle would be lower. But during the summer, the sun is really high in the sky. It passes almost vertically overhead. Not quite, but it passes close to vertical overhead. So if this was designed to collect energy from the sun during the summer, it should be tilted so that it's pointing almost straight up. It's obviously not in this case. In this case, it's pointing really at a rather shallow angle to the horizon, which means that it's probably designed to collect most of its energy during the winter. But again, if it's been tampered with, if they've moved it as he said they have, then it's probably not pointing in the right direction at all. So this is a bad example. This is not proof of anything. I'll give you proof and a way to test whether or not the Earth is tilted. And it's a really simple test. Anyone can do. Grab your local newspaper and look at the sunrise-sunset time in the weather section. And then go outside and test whether or not the sun rises and sets within a few minutes of what they say it should. If it does rise and set at the times they say it should, then the tilt of the Earth is fine and nothing has changed, because the sunrise-sunset times are very sensitive to the tilt of the Earth. If the Earth is tilted and out of whack, the sunrise-sunset times will not be accurate. And they won't be accurate just for you. They won't be accurate for anybody around the world, because a changing tilt of the Earth does not just affect one person. It affects everybody the same. If you don't have access to a newspaper, use an online site like this, like sunrisesunset.com. If we click on this USA link and then select a location like Wisconsin, and then just choose a random city, I don't care which one, and then let's also choose moonrise, moonset. This will calculate the sunrise, sunset, and the moonrise and moonset times for your location. But there is a caveat. You have to be careful and should actually go down here and read the accuracy statement, because the algorithm that they use in this model is not as accurate for stations and locations that are poleward or north of 60 degrees latitude. So northern Canada shouldn't use this. But it should work fine for southern regions. But the other caveat is that it's also sensitive to your height above sea level. If you live in Colorado, the sunrise-sunset times that this produces might not be as accurate as if you lived in Hawaii, because the height you are above the surface of the Earth affects how quickly the sun rises or sets. If you're higher above the Earth, the sun is going to rise sooner than if you're really low down at the surface of the Earth. And the other thing to watch out for is that this assumes that your horizon is flat. If you have mountains or hills or trees that are in the way of where the sun would rise or set, then you have to take that into consideration. Sunrise and sunset times and moonrise and moonset times that this provides are not going to be as accurate if there's hills in the way. Or if you live in a valley and there's mountains all around you, of course it's not going to be as accurate, because you can't see the horizon. So you have to take these things into consideration. If you're not in a location where you can see the horizon, the flat horizon, then you have to take a little bit of grain of salt with these calculations, because it won't be customized for your particular location. That's why I say it might be better if you actually use the sunrise-sunset times from your local newspaper, because they will usually refer to your local weather office, which will take all of these things into consideration. But again, like I said, if you don't, you can use this method. So after you've selected your city, you click on Make Calendar, and it pulls up and calculates for you the sunrise, sunset, and the moonrise and moonset times for your location throughout the whole month. So take that information and go outside and test it. And if it's within a couple of minutes of being accurate for you, then the Earth's tilt has not changed. Forget about where you think the sun should be and where the moon should be. They change according to seasons. And the moon even changes according to other things, which I'm not going to get into in this video. But the position of the moon doesn't stay in the same place all the time. It varies according to its orbit around the Earth. And it also changes according to your location. So forget about where things are rising or setting, and focus on the times that they're rising and setting. Because if the tilt of the Earth has changed, it will affect the time that things rise and set. And I can tell you right now that nothing has changed, because for my location, these sunrise sunset tables and moonrise moonset tables work. They're accurate for my location. And if they're accurate for my location, then they have to be accurate for everyone else. Because, like I said, the tilt of the Earth does not change for just one person. It changes for everybody. So if everybody's sunrise sunset times or moonrise moonset times were off, then we might have something to worry about. But because mine is not off, it's accurate, I know that nothing has changed. So Mr. BBB333 and his Michigan farmer need to go back to school and learn a little bit more about how seasons work. They may understand the land really well, but they obviously don't understand how seasons work. Because if they did, they would know that this simple test can prove whether or not things are out of whack. And they're not. So relax, people, and stop trying to focus on these people who like to try and scare you into believing things are changing when they're not. This life's too short to worry about things like this. Just enjoy life.